Right, what we're going to look at now is how regular expressions can be used to transfer one file format to another. So following on from our example where we used Emacs to go through a BNF file and use that to generate a lex file to produce a lexer, I've done the same example on 3 different tools that use regular expressions to help you see the power of regular expressions in programming and how they can make your job of doing the coursework go a bit faster. So for speed, I've written them down in a little file here. The first tool is SED, or stands for Stream Editor. It's a Unix tool, but it should be available to you if you've downloaded the MinGW or the GNU compiler tools that we're using to build it, and the same for awk. Perl usually has to be downloaded specially, but you can get it as part of that MinGW or MSys package if you tick the right box. So this first command, I've put it in a batch file to save me typing it when I could type it. So I could type sed -n. That says I don't want to see any lines except those that match the pattern. E says execute the pattern, and then I give a string quote that is the command to be executed. It starts at that quote and it goes on to that quote, and then I give it the file containing the BNF that I wanted to edit. So everything between there and there is either the pattern or says what to do with the pattern. So first we want to look for something starting with a quote, and so it doesn't get muddled over quotes, I put a backslash in front. Then a square bracket says we're a set of characters. The up arrow says invert the set, so not quote 0 or more followed by a quote, so that's a quoted string. Then a slash says the end of the pattern, so that says any line that contains a quoted string. What we want to do is substitute that quoted string, so it is from that slash all the way up to that slash is the substitute command. So we have a line that starts with only number of not quote characters, then remember from the quote, and then we've got the characters in the quote, that's a set of not quote, then the quote, then we want to stop remembering, then any old characters up to the end of the line. That's what that regular expression says. We want to substitute that. \1 means the first pattern we remembered, which is the one in the brackets or the one we were looking for. So that outputs the string, then we want a tab character, then the word token, then the string again, and we want to print that out. And that magically produces the thing. So I can just run this little batch file that I've made, and you can see it executes the sed command, and then it produces exactly the same output as the Emacs program did earlier. Now we can do exactly the same job with almost an identical regular expression using the program awk. So this awk matches, that's the program, the quote is the beginning of the program. It matches any lines containing quoted strings. If it finds one, we're going to try and match that quoted string within the whole line. So that is matching the whole line a quoted string, and print out that quoted string followed by a tab, a token, and then that quoted string. So it's very similar in construct there, so I can run that one, and again that produces a similar set of output. Now the last program is in a language called Perl, which is pattern replacement language. So this is Perl on the whole program, execute on the whole file, execute this little program that says print this string of the pattern, a tab, token, and the pattern if the pattern is contained in the line. and here is the pattern. So I can press enter and it executes that program. So very easily I've got 3 different programs in 3 different pattern matching languages, all using a very similar syntax of regular expressions. All will go through a BNF file and output a basic flex file that matches those tokens. Now none of these look for the keywords, it only looks for quoted strings, and in the longer example using Emacs I match those as well. But it's not much harder to add to these programs now to change the pattern just to match unquoted words, and that's left as an exercise to the reader. So now we've shown how powerful regular expressions are, what a variety of tools are available to a programmer that utilise regular expressions: the Emacs editor, the SED editor, the awk file processing tool, and the Perl pattern matching language. So I hope you find all that useful and it can accelerate your programming.